Good morning, all. So, this is the second lecture of my online class. So, the topics of today's class is Skewness and Kurtosis. So, those who have not listened the last lecture, please click on the iPad button above and see the first lecture. After that, you come into this lecture so that you can complete understand of this topic. Okay. Now, before I begin to that main topics, so there are few points I will just tell you. One is that, like I told in the last video, that 1 hour 30 minutes is divided in the 3-4 section. Like the first 30 minutes is for that today's lecture, and next 10 minutes for that online session where you will ask your doubt or questions answer session in that live chat through the live chat. After that, 20 minutes for the IEM-CRP online exam, and next 30 minutes is for that that assignment submission, right? So like I see that there is lots of questions is coming from in this online method from the student side. So I have increased this online session to 30 minutes. So if you have any questions, come to that online question session and ask your questions in the chat box. If you do not have many questions, you can go to the directly to that IEM-CRP exam. So you don't have to be present all 30 minutes in my questions answer session. After asking your doubt, you can go to that IEM-CRP exam and finish the exam. After that IEM-CRP exam, like that last 30 minutes is for that assignment, today's assignment submission. And I feel that there is strong pressure among the students also to submit that assignment within this 30 minutes. So I have increased this time to up to today's night 11:30 p.m. By this time you can submit your assignment so that you have given the enough time to complete your assignment yourself. Now let's begin today's class. So before I start with this lecture, let me just recap of that last lecture that I have seen that we have seen that this lecture is moment is useful for finding the central tendencies, like that new one, right? That is for the mean, right? So by using this moment I can find out the central tendencies, mean. And next one is that by using the central moment of order 2 I can find out what is the dispersion or what was the variance, right? And number 3, that is today's topics, by using that moments I can find out discriminate between the two distribution by using the skewness and kurtosis. So what is that finding the difference between the distribution? Suppose I have plotted that students marks in the histogram, right? I have seen in that some students have doubt using this how the skewness and kurtosis is useful. So for them, suppose I plot your marks in the xy plane by using one histogram plotting, and another section I plot the similar way another distribution, right? Histogram basically the distribution of the marks. Now to find out how the data are skewed, how the two distribution are distinguished by using the skewness and kurtosis, we can find out what is the difference between two distribution pattern or two marks distribution pattern of the of your section. So that was the third application of the moment. Now after that we have seen that there are three sort of moments are there. Number 1 is that moment about any arbitrary point that we have denoted by mu dash r, right? Number 2 is that moment about about mean, the arithmetic mean, that is known also central moment. And number 3 is the moment about the origin, that is known as raw moment. So that is the three sort of moment we have talked about. After that, in the last lecture we have talked about the relation between the central moment and the arbitrary moment, right? And in that slide I have got the many students ask me, sir, can you make one video based on that one, how the relations comes, right? So those who have not seen that how this different relationship can be remembered, please click on the I button to see that portion of my lecture, and after that you can understand why this slide is useful and how that relations come from this general version, right? So here I will talk about how the central moment and moment about arbitrary point are related. We start with the central moment. After that we write the central moment, so that is mu r, that is denoted by r to the central moment. And after that we write this mu r, that is the r central moment, by the arbitrary moment, that is mu r dash. Okay, so I'll write this mu r by using the definition, no problem. Fi xi minus x bar to the power r by n, right? That is the definition. After that, I can use a simple mathematical way to write this term in the arbitrary point. So I put one arbitrary point a inside this bracket. So here I'll put a is arbitrary point in that function, and after that I again taking the negative of this one, so it will be positive, right? Then a will be cancel out, so it is same this one, right? Next one, I expand this one by binomial series, right? So binomial series, I expand this one. So this is the first term of the binomial term, and this is the second term. Remember, this second term basically constant. This second term is constant. So x bar is a constant because mean is a constant, a is also constant, and here xi is the variable. I have taken the sum over all this binomial term. Now, so first I write the first term, that is x minus a to the power r. Now fi, that I have also multiplied with this term. Now next term, that will be rc1, negative of rc1, negative is there, so it is negative of rc1. Then this term, that is comes 1, x bar minus a, and that is a constant, so that's why it's come out from the sum. So sum is fi is only multiplied with this xi minus a to the power r minus 1. Similarly, the third term, that r side 2 x bar minus a square, sum of fi xi minus a to the power r minus 2, right? So on, that is divided by n. Okay, and after that I divide this each of this term by n. Okay, so first term, that will be divided by m, that will be your mu r dash, that is the raw moment, not a raw moment, or raw moment is also arbitrary moment, particular case if I take a. So this is the arbitrary moment about a, arbitrary moment. So if I take fi xi minus a to the power r by n, by the definition of the raw moment of order r, that is the mu r dash, right? Similarly, second term, that is rc1 x bar minus a, and that is divided by n, so that will be mu r minus 1 dash. And similarly, the third one, rc2 x bar minus a square, mu r minus 2 dash, right? So on. So that is the relation between the central moment of order r with the arbitrary moment of any order, different order, right? Now I'll take the particular case, that if I take r equal to 2, if I take r equal to 2, then it will be mu 2, right? And this side will be mu 2 dash minus 2c1 x bar minus a, mu 2 minus 1 dash plus 2c2 x bar minus a square, mu 2 minus 2 dash, right? So on. After that, there will be no term. Now these things we can simplify. This left right hand side term we will now simplify. So I write the right hand side term, and so I can write this is same as this one, and 2c1 equal to 2, that is x bar minus 1, that is 2 minus 1 1, and 2c2, that is 1 x bar minus a square, and that is mu 0 dash. Now what are the different mu 1 dash, mu 0 dash, so on, we have to find out. Now I'll start with the general definition of the arbitrary moment. Mu r dash by definition is this one, phi xi minus a to the power r and by n. Now if I take r equal to 0, so this power will be to the power 0, right? So something to the power 0 is 1. So this is basically sum of phi, this one to the power 0, and that is sum of phi only will be there, that because this is 1. So sum of phi equal to n, so n by n equal to 1. So this term basically equal to 1. Now what will be this term? Mu 1 dash. Now mu 1 dash I can write by the definition is this thing, right? In the power, this is the general term r. So in the power I write r equal to 1. This is that mu 1 dash. Now here if I just take the sum inside the bracket, then it will be sum of phi xi, right, minus a, sum of phi into a. Remember, a is a constant, right? So I can take this a outside of this sum. So then after that I am dividing this whole term 1 by 1. So this term will be divided by 1 by n, minus a sum of fi by n, right? And this one, what is this thing? So this is our mean, right? So this is our mean x bar, and here fi is equal to n, sum of fi is equal to n by n, that is 1, so x bar minus a. So I've seen that mu 1 dash equal to x bar minus a. So this is x bar minus a, and that is 1. So x bar minus is already present here, so it will be twice x bar minus a whole square plus x bar minus a whole square, that is also 1. So only one negative of one term will be there. So see, so here I write this way, mu 1 dash value this one, and mu 0 dash is this one. So it will be to a negative of twice or positive of this one. So here only one negative will be present, this one. Now I can write this one, x bar minus a, that is mu 1 dash, that I have seen in the last slide, right? So this is equal to mu 1 dash. So I have seen that mu 2 dash is related to that arbitrary moment of order 2 and order 1 by using this way. Similarly, you can find that how the mu 3 is related by using this relation. So you'll start with the same way, you write the relation, right? Let me see, show you how you can do that mu 3. So you write the mu 3, after that you expand this one by using up to 3 order, take the fourth term, right, and write individual what will the referred term, and you can find out the relation mu 3 and similarly mu 4. Now let us go to that main topics today, that is our skewness and kurtosis. Okay, so today's topics, that skewness and kurtosis. So skewness, first we will talk about the skewness. So this is the measure to finding the asymmetricity. What is the asymmetricity? So first we have to know what is the symmetry. Suppose I plotted one section mathematical marks, right, in the histogram, and suppose their histograms is marked. You have seen the histogram is some block shape, this side, this is something like that. Suppose I take the peak point each of the bar of this different bar, right? After that I join them by a line, and I got this sort of curve of the histogram of the marks. Then I see around this point, I denote this is the mu. Around this point, these two sides are exactly equal. That is the symmetric about this mu, that is known as the mean. You will see this is the curve of the normal distribution. You don't know this thing, you will learn this thing in the next semester about in the probability chapter, that what is the normal distribution. So normal distribution, this is the shape of the normal distribution, and also this is known as bell shape. You can think this is a one bell, right? So this is also called bell curve or the normal distribution. So this is the distribution of the symmetric curve, that is one the normal distribution. Now if some distribution is not, so you can see that most of the distribution would not be something like that. So if suppose two distribution like this way, so that is not symmetric, and one is called the positive skewed, another is negative skewed. And how the measure we can do, we could talk about in the next class. Before that, we understand what is the positively skewed and what is the negative skewed. If you consider this distribution, this is again suppose the distributions of your marks of some section, and I got this histogram pattern is some sort of like that. And if I consider this is one shape of mouse, okay, one shape of mouse where the mouse tail is this side, and this is also another shape of mouse where mouse tail is in that left hand side, that is towards the origin, and here this is that outside of this. So this is the positive direction of the x-axis, right? If the tail is the positive direction of x-axis, and then this is known as positively skewed, okay. If the distribution tail, so this is the known as the tail of the distribution. If the tail of the distribution is towards the positive axis of the x, then it is positively skewed. When the distribution is tail is towards the negative of this x-axis, then it is called the negatively skewed. So first one is that this is the symmetric. So last curve, this is the symmetric distribution, normal curve or bell shape curve. Now this is the positively skewed if the tail of the distribution is towards the positive x-axis, and if the distribution tail is towards the negative of the distribution, then it is known as negatively skewed. Now I have plotted the mode, median and mean also, right? So this figure is basically taken from this BS Grewal Awards mean textbook, and I just plotted, take the snapshot of this book and plot it, so that you have an understanding what is the positively skewed and what is the negatively skewed. So negatively skewed is the tail should be the tail of the distribution toward the negative of the x-axis, and positively skewed is distribution is that positive direction of the x-axis. Now how to measure this positively or negatively? So there are three sort of measures are there. First one, that is known as Pearson coefficient of skewness. So this is the one measure, Pearson's coefficient of skewness. So Pearson was a very famous statistician. Okay, so this professor name we also come about in the next lecture, like the correlation, Pearson correlation. This is also one famous name in the statistics field. So he give the idea how we can find out the skewness, and he proposed this measure, that is mean minus mode by standard deviation. Mean minus mode by standard deviation. You have learned in the mean median mode chapter that mean minus mode, we can write this one equal to 3 times of mean minus median. So that is another way I can find out the skewness, by finding this term. So I can find out what is the mean of the distribution, that is the arithmetic mean. I can find the mode, right? By know that how the mode can be found for the different sort of this data. For the we have continuous data, how to find out mode I know. Also I know from the dispersion chapter how to find the standard deviation. So after finding out all the 3 terms, I can find out the skewness. Okay, next one is that by using quartile coefficient. The quartiles I have also talked about during the offline class. So quartiles, basically we divided the distribution in the 4 equal term. Q3 is the our third quartile, and Q1 that is the first one, and Q2 that is also known as the median, right? Divided by Q3 minus Q1. If I find out the quartile of the distribution, I can find out the skewness by using this formula. Okay, and number third, that is the coefficient of skewness based on the third moment. Okay, so that is the application of the moment in the skewness field. So how the coefficient of skewness based on the third moment is generated, that is known as gamma 1. So gamma 1 equal to square root of beta 1. And how the beta 1 is formulated? Beta 1 equal to mu 3 square by mu 2 cube. Mu 3, that is the third order central moment, that square divided by second order central moment, that is basically variance 2 cube. Now how to remember this one? If you take the sum of this one or order, so that is 3 into 2, that is 6, also 2 into 3, that is 6. So that is the order of the denominator and also numerator, both are 6. So that way you can remember that beta 1 you can find out, and after the squaring you can find out the coefficient and skewness by using this formula. Now we'll talk about one example how to find the skewness of the beta 1. Suppose we have this data. Okay, that same data I have given the assignment in your class, and most of you have already given the right answer of that, how to what the your central moment, second central moment, that is the variance you have you have find out. Now using that data, same data, I find out how we can calculate the beta 1. So mean you already know, that is 4, right? And sum of all the frequencies is 256, right? Now mu 2 that you have calculated very nicely, that is equal to 2. Okay, that is your variance. Now we have to find out beta 1. So let's see what is the definition of beta 1. So beta 1 equal to mu 3 square. So we have to find what is the mu 3 first. So I find out mu 3 by the definition, it is fi xi minus mean of x cube by n. Mean of x, that is 4, and n is that 256, sum of all the fi. So here I write fi xi minus 4, that is the mean of x, by 256. Okay, now here I put different data point given here. So first f1, So f1 is 1 and x1 is 0. So 1 0 minus 1 cube plus 8. Next f this is f2 and 1 minus 4 is our mean cube plus 28 2 minus 4 cube and so on. Okay, now here you see that so this is will be negative of 4 cube, right? And last term you will see this is the positive of 4 cube, right? And second term it will be 8 into negative of 3 cube, right? And the second last term, see this one, this is 8 into positive of 3 cube, right? Now third term, so negative of 2 cube, and the last third last term, that is positive of 2 cube into 28. Similarly this one, and here it will be 0. So you will see that here is basically this is negative, this is positive, negative, positive, the same value. So it will be just subtract each other, eliminate each other. So you will get this is basically 0. So mu3 is equal to will be our 0. So if I know mu3 is 0, then by the definition of the skewness, that is beta 1 equal to mu3 square, mu3 is 0 by mu2. So whatever mu2 that is 2, but mu3 as it is 0, so beta 1 is 0. So I'll see this data is basically symmetric, right? So for the symmetric distribution, our this beta 1 value will be 0. Okay, if it is positive, the beta 1 is positive, then we will call about this is the positive skewed, and if the beta 1 is negative, so in that case it is only 0, so this is symmetric. So if it is 0, then that data is symmetric. If the beta 1 or the gamma 1 is positive, then it is this distribution is positively skewed. If it is negative, then it is the negatively skewed. Okay, now the next example, next topic, that is the kurtosis. So like the skewness is for the measure for the asymmetricity. Here kurtosis is used for measure for the peakness. Suppose we have these three curves. So you see that all the three curves is equal, only the peakness of this data is different. Peak means high point here are different, right? So number this one, that is the most flattened, after that is the normal one, and the red one, it is highly peaked. So this highly peaked, that is known as leptokurtic. Okay, and if it is exactly normal, then it is known as mesokurtic, and this one, which one, that most flattened, that is known as bradykurtic. Okay, that is the negative. So how the negative positive that is come from the definition. So this image I have taken from this website. Now next one is that how to measure this kurtosis. This last one we have seen the gamma 1, that is equal to square root of beta 1. Here it is denoted by gamma 2, that is beta 2 minus 3. Now beta 2, how we can calculate by using mu 4. So mu 4, that is the fourth central moment by mu 2 square. Okay, mu 2 is the variance, that square, and here also order is also 4, right? Numerator order 4 and denominator 2 cos to 4, if I remember in this way. Now after finding the beta 2, if I subtract by 3, I'll get the gamma 2. Okay, so that is only one way to measure, that is kurtosis, by using this gamma 2. Like the skewness we can find out by 3 different way, and kurtosis we can find out only one way. Now we will take the same example here also, find out the beta 2. I have taken the same example again and again. So here we'll know that this mean I know, that is 4, and the sum of fi, the total number of point, that is 256, and mu 2 is 2, I know. Now I use the mu 4 definition. So instead of it was cube, it will be 4 divided by n. Now mean of x, that is 4. After that I'll take the different data point. So 1 for the first point, then 0 minus 4, and same way, right? Previous way 8, 1 minus 4. Instead of cube, it is now 4. Now here all the data will come twice, right? So previously it was cancelling each other, but here it will be positive, here also it will be positive, here also positive, and same positive, but equals value. So it will be twice of this thing, right? So twice of 4 to the power 4 256, then this one, then so on, and divide by 256. After that I'll got mu 4 equal to 11. So beta 2 will be mu 4 by mu 2 square. Mu 2 is 2, so mu 2 square, that is 4, so beta 2 is 2.75. so I'll see that beta 2 value is positive, so it is positively skewed, means that it is basically our, if I go to that our this curve here, so this is positively, so here our, okay, so before that I have to do this this one, right? So I have to find that 2.75. after that if I take that minus 3, so it will be negative, so I have to find out the gamma 2. Based on that I can tell about whether it is platykartic or it is mesokartic or leptokartic. So gamma 2, as it is negative, so it is platykartic, means this data is flattened compared to that normal data. So this is the normal curve, that mesokartic, that is the normal one, and as that gamma 2 is negative, so our this data is platykartic, and by using the skewness I can tell about this data is symmetric. Like if I see also, if I plot this data in the xy plane, then I can see that this data will be symmetric, like 0 this frequency 1, then 1 frequency 8, similarly 8 frequency 1 and 7 frequency. So if I take, this is the middle point and both sides data is spreaded equally, so that's why it is symmetric. So it is skewness is 0, but if I compare this data with the normal curve for the kurtosis, though it will be flattened one, that will be the platykartic. So that's why this beta 2 value we have taken, that is positive 2.75. after that if I take the negative of 3, then it will be negative of 0.25. so this data is platykartic. So that is the today's lecture. So give me the comments in the video to what, if there is any questions today's lecture, tell me that one, or otherwise you can talk to me in the live session in the YouTube live after this class is finished. Okay, thank you.